All right, good afternoon, everyone. My name is Tom Hunt, and you've reached the Mobile World Congress 22 wrap-up event brought to you by the Wireless Communications Alliance. Today, Prakash Sangam and myself will discuss what went on at the event. Prakash is the founder and principal at Tantra Analyst. Welcome, Prakash. It's always good to have you.
Thank you, Tom. Glad to be here.
And so let's talk numbers about Mobile World Congress. First of all, it was the first live Mobile World Congress in 2 years. So they had 61,000 attendees showing up in Barcelona for the event. And you can see some of the interesting things that are going on. You can see also that streaming is a big part of Mobile World Congress now. And they had 6.7 million online impressions. They had 352 hours of content delivered. So it's pretty impressive the way the world has adapted to online. Even though we love in-person events, we feel their pain as well, because we haven't had an event at the WCA in person in over 2 years. So we're looking forward to having in-person events and working our way through this. Some more statistics. Who was there? Over 1,000 startups, 70% international attendees, 1,900 exhibitors, and almost half were director level and above. That's impressive, considering trade shows don't typically get that level of person showing up. So I'm going to show a quick video just so you can see what was going on.
Welcome back to Barcelona. Welcome back to MWC 2022.
We believe that this new age of connectivity is characterized by both evolution and revolution. Intelligent innovation and automation is now happening everywhere.
We inspire our members. We inspire our fans.
Not only do we create content, but we create creators that create content. Millions of underprivileged were provided access to online capabilities, which enabled education and healthcare.
So the big companies have always had the tools, but now we're giving those tools to the small companies.
It would be great if next year we gather here and we realize we have developed a global standard that will ensure us and our children and grandchildren to feel safe and comfortable about this new reality.
Thank you for coming, and see you soon.
Okay, so hope you enjoyed our little video. For those who couldn't be there, what we're going to try to do today in a discussion with you all is to talk about 4 technology trends that seem to be prevalent at the event. The first one, Open RAN. We can talk about Open RAN. As you know, the WCA has had several events on Open RAN with the TIP Alliance, which was started by Meta, formerly Facebook, and the Open RAN Alliance, which was started by NTT Docomo. Want to drill down just a little bit more on Open RAN, some of the announcements that were made and what's going on. We'll then shift to Metaverse. And Metaverse is a confusing thing, and people often ask, what the heck does the WCA have to do with the Metaverse? Well, Metaverse is all about connectivity. And while it's VR and AR, there's a lot more to the Metaverse that meets the eye. And we want to drill down just a little bit about who's playing, what the impact on the network is, what's missing from the network, and how do we advance to achieve some of the goals that have been set out by many of the companies who are getting involved in Metaverse. We'll then wander into Wi-Fi 7 territory. Now, you might scratch your head here and say, Wi-Fi 7, I'm still waiting for a device that I can support at home with Wi-Fi 6 or 6E. Well, Wi-Fi 7 was predominant at Mobile World Congress. Qualcomm, ZTE, and others made big announcements in this space. So we want to talk a little bit about what is Wi-Fi 7, when does it become real, and who are the players, and how does it impact everything that's come before it. And then finally, we'll wrap up talking about a subject that many people don't even know about. That's 5G Advanced. And 5G Advanced, it's not necessarily millimeter wave or the recent spectrum that's been opened up on 5G that many people have been touting about, and you've seen lots of bad press about interference with airplanes, etc. But we want to talk about 5G Advanced, where we're going with 6G. What is 6G as we know it today? People are speaking about it, people are talking about it, and so we want to drill down. And so without further ado, let's get into this just a little. Open RAN. So Prakash, interesting announcements. I've highlighted a couple here. Marvell announces no compromise 5G Open RAN with partners at MWC. Intel advances vRAN. HPE and Samsung join forces to accelerate 5G adoption. First, I'm sure you have opinions on this. So the first thing to me is, what's wrong with the original RAN, and why are we going to Open RAN? And we've had computing power for 30 years now or more. What's going on with these partnerships with compute companies and communications companies, and what does this all mean? What's causing this disruption?
Yeah, sure. So I mean, Open RAN has been talked about for some time, so everybody, I'm assuming, understands the issues with the ecosystem. There is nothing wrong with the network itself in the legacy network, but it's more to do with ecosystem. The infrastructure players are becoming fewer and fewer. There are only like 4 left right now, and five left right now, and 2 of them are not allowed in the US, for example, right? So it's only Samsung, Ericsson, and Nokia are allowed in the US. And if you look at the capital expenditure operators have to do, it's huge amount of capital has to go. The network, the technology development itself is a huge capital investment. So it is unsustainable to continue to grow, continue to be with the legacy system that we have when you're looking at 5G and its evolutions touching almost everything in the world, right? So that's why we need something new. That's why what we have right now, although it works and it will continue to work, but to go to the next level of connectivity, we need something destructive like Open RAN, which kind of opens up the whole cellular infrastructure business for new entrants, new players, big and small. It's not only for big players like cloud players, or small who only do some part software or some dedicated hardware and such. So it opens up for everybody, reduces the entry barrier, and make the cellular networks look more like enterprise and cloud networks. So when I started in my career, there was a choice between you go towards compute and IT or towards telecom. Those were 2 different words at that time, but more and more they're all together now, right? So the Open RAN, it basically converts cellular networks into another cloud type of network and enterprise type of network, right? So why it was not thought about and was not as hot as it is now? I mean, that's a very valid question. As you said, compute has been for there for some time. A few reasons out there. Earlier, these big infrastructure players had a very strong presence, and they never wanted to open up, for interconnect and so on. And then it is one reason. So they always had proprietary technologies, proprietary interfaces between the radio network, baseband, and others, and it benefited all the infrastructure players. So they never wanted to open up because it is stickiness, because assurance of business and so on. And then compute was there, but especially the RAN needs extremely low latency compute, high capacity compute, and cost efficient, battery efficient, or the power efficient compute, which was not there. It's been coming online from maybe last 5 years or so. And even that, when you look at these advanced features like advanced MIMO 64TR and such, they need even more efficient, specific compute, and a huge amount of capacity and efficiency, and also doing that in a more open way, and that needs a lot of not only compute but low latency communication between the radio and the baseband and so on. So that has put a lot of pressure on making sure it works well. So even although Open RAN is there, are a few networks, large scale networks that Rakuten has done, and Dish is doing another major network using Open RAN, they still are not at a level in terms of advanced features, be it carrier aggregation or this massive MIMO 64TR and so on. They're still getting there, right? So that is another challenge and such. And also people are realizing the moment they're when they're starting to deploy these networks and trying to scale up, it is not just the general compute. The original idea was, you bring in, just like cloud, you bring in general compute called as CODs, as off-the-shelf computing, and then you can run RAN just like another workload. But they're realizing that running on general compute is not as efficient. It's very expensive. It's kind of beats the very purpose of bringing in this new disruptive approach. So now there is focus on, especially on the RAN and the layer one stacks. There is realization that you need what are called as accelerators, which do all the radio functions, the layer one radio functions. And then the other layer 2, 3 can be general compute, right? So that's how, where you're seeing the Qualcomm announcement with HPE, Marvell, and few others who have these accelerators. And then obviously Intel making sure it has the compute for layer 2 and 3 kind of signaling and so on. And all of these are basically cloud native, which means they use the same architecture, be it Kubernetes or hypervisor based architecture and so on. So that has basically allowed the cloud players to play a key role in this, because it's basically from a development point of view, the whole network development and deployment looks like a cloud deployment, right? And the enterprise deployment. So a lot of things coming together, and one biggest impetus for all of this, in my view, some people might differ on that respect, is the supply chain issues, banning of Huawei and GT into the US. There's huge impetus from the US administration itself to come up with solutions where they are open, they are led by cloud companies and large enterprises, and the technologies where US has expertise in, so that you have supply chain security and get stuff done from the suppliers and from the countries that US has a friendly relationship with, right? So that has given a huge impetus. We can talk more on that aspect if there are more questions and so on. So that kind of brings in, and Mobile World Congress is the best place. It's the biggest radio show, biggest the cellular show, and biggest the tech show, which is it has become now, to talk about it. And everybody were there with full force talking about it, not only talking, showing proof points, proving that they have done it, and showing the roadmap and so on.
Thanks, Prakash. One of the interesting things to me was when we talk about Mobile World Congress, it seems that the window has gotten much bigger. And it's not just what happens at the event, it's what happens before the event by a week or two, and after the event a week or two. Many players didn't want to get swallowed up by the typical news of Mobile World Congress, which was mobile phones, tablets, laptops, networking equipment, etc. And so they picked and chose where they were announcing their products. And one of those announcements came from an interesting partner. And you talked about the cloud and how the cloud is sort of becoming the mainstay for Open RAN and the network moving forward. And Amazon made an announcement about private 5G networks. And to me, that was an interesting development. And as you know, the WCA does lots of events on spectrum, and one of the things we always track is the CBRS community and private networks. And we're seeing recently just a slew of private network offerings. So I wanted you to just talk a little bit about private networks as it relates to Open RAN and as it relates to this disruption in the industry.
Yeah, absolutely. So, I mean, private network as such has been talked about, even in the 4G days, and so on. But it has, with CBRS spectrum coming in, that was one of the use cases, and CBRS took some time to really come online. I remember talking about shared spectrum at least like 5-6 years ago, the concept itself and so on. But glad to see that it's coming online. And when people talked about 5G private networks, even 4G advanced private networks, this was always about, it was always synonymous with, there are applications and features that you need like URLLC, ultra reliable, ultra low latency, as people know. That's the reason why you need private networks and so on. But that's not the case though. When you look at, there are lots of traction, there are many people trialing. There are some of the commercial networks as well in enterprises, even in educational institutions. Like a couple of months ago, maybe a couple of weeks ago, maybe a month ago, Samsung announced a commercial deployment in Howard University in DC of a private network with Amdocs for campus, for university campus, right? Just for broadband itself, and so on. So it's a misnomer that private networks are industries only, and they need features like esoteric, I would say, features like URLLC and so on. No, I mean, you can do private networks, and there are lots of benefits doing it for just broadband purposes with enhanced mobile broadband technology, the release 15 and 16 that we have today, right? So and what is the relationship between Open RAN and private networks? As we talked about, Open RAN is a very new concept, and cellular industry is very conservative because they have to make sure their millions of customers are not affected when they move between technologies and so on. So they're very risk averse in bringing in new technologies. And private networks being a new greenfield deployment, being a limited deployment, which gives much more leeway in terms of testing new concept, is an ideal fit for testing Open RAN architecture. That's one aspect of it. The other is, as you say, it's cloud native, it is enterprise networks. These are the new entrants coming into the cellular ecosystem, and they have, they're experts in deployment, cloud deployments, and the enterprise guys like HPE and, and others, they are experts in enterprise networks. So this kind of presents itself, the private networks presents itself as an excellent opportunity to test these new concepts, and then get the learning from their successes, failures, get the learnings from these failures and so on, and apply them for a larger public networks, right? So it's, I think, an excellent intersection of many new things in terms of timing, technology, and effect, learning and effectiveness and so on.
Fantastic. Thanks, Prakash. Wanted to talk a bit about I want to talk to the audience quickly. I didn't go over this in the beginning. Should you have questions for on any topic we're speaking on, please go to the Q&A tab and feel free to type in your question or raise your hand, and somebody will tend to you and make sure your question gets addressed. So little housekeeping there for everybody. Prakash, so now let's go to Metaverse, and to our audience members, Metaverse is, largely been thought about Facebook and Meta, and creating this AR VR world. And to date, it's all about gaming. And even at Mobile World Congress, we saw, oops, let me just get to that slide, sorry. We saw lots of announcements, but the biggest one I saw was the Metaverse stole the show at the world's biggest mobile event, and things got weird. And I think, it gets a little confusing to the general public. SK Telecom made an announcement that said they're betting on 3 new technologies for future growth. One of those is the Metaverse. And they announced, of course, a game, and they had a virtual game there. And then, we see more and more small companies in AR and VR getting involved and getting acquired by bigger players who have ambitions in the Metaverse. But I think one of the most important things that I heard coming out of Mobile World Congress was that Meta itself says that the ambitions of Metaverse cannot be fully realized without better cellular networks. And I think that's the important piece here, that we need to discuss just a bit. The Metaverse is a concept now, and sure, it exists in AR and VR applications, and they are taking off, and there's business applications that can be fully realized in this world. But let's talk a little bit about what does Meta mean, that we can't really get this realized until we have better cellular networks. 5G is not fast enough for them. 6G is not fast enough for them, or 6G is fast enough for them. Where are they headed?
Yeah, I mean, Metaverse is a loaded term, right? It's microcosm of everything, and it has become, to some extent, out of hand. Everybody, no matter what they're doing, try to somehow link it to Metaverse, right? So, I mean, the large, and it can evolve into many other things, but largely it is basically 2 concepts in my view: XR, which is AR, VR to combine together, extended reality, and then second is digital twin. So you basically, for everything that is you have in a physical world, you replicate that and create a digital twin, and that brings lots of opportunities in terms of efficiency, using improving the user experience, business processes, and so on, right? So I mean, you can skin Metaverse in many ways. Since we are at WSEA now, let's look at from connectivity and wireless perspective, right? So knowing that it's all about AR, augmented reality, virtual reality, extended reality, mixed reality, whatever you want to call it, and digital twin, creating a digital twin or digital presence of everything that is in physical realm, right? So, and you look from connectivity point of view, what do you need? So, people who have used AR, VR glasses with, tethered to their consoles and so on, they know how inconvenient it is. So it is given, it's universally accepted that anything that you want to put on your eyes, on your head, needs to be wireless, right? So you need connectivity. So that connectivity becomes a key ingredient to make any of this thing happen, right? And then we look at connectivity, and it's not just regular connectivity. For you to have not a great user experience, even for AR, VR to be functional, right? You don't get nauseated or you don't get blurred vision or whatever, even to basic functionality needs extremely low latency, right? Without latency, there is no XR at all, which means there is no metaverse at all. If there is connectivity, it doesn't have low latency, right? And then the extension of that is how do you, there are two ways how you bring in connectivity, right? We'll talk about those. And other thing is capacity, which means, I mean, if you're only one user on the network, then the network can give all the capacity that it has. Then you have excellent latency, that's given. Obviously, you need to have backend latency that need to be optimized and so on. So of course, yeah, right. So latency can be, if you're a single user, then you can get latency, but you have to have, if you're looking at making it a mainstream, then you have tons of users all simultaneously using these AR, VR, then we get into a capacity crunch. So so the challenge from a connectivity point of view, it becomes a twin challenge. One is optimizing the latency from both end to end as well as network latency, based on the capacity, based on the traffic, and you need capacity to handle huge amount of traffic. So when you look at the AR VR itself, the user experience, there are many studies on that. The user experience of these metaverse experience that is directly related to the resolution, the frame rate that you have for the content, not just gaming. Anything that you take that is on AR and VR, the higher resolution you have, the higher frame rate you have, higher is the user experience and the customer satisfaction, which means the amount of data that you need to haul between your headset and the server is huge. And if there are, it's mainstream, many people are simultaneously using it, you multiply that traffic by those many users, which means you need extremely wide bandwidth connectivity with lots of capacity, and all of that capacity had to be delivered with extremely low latency, right? So that's where the capacity becomes a enabler for anything that you talk about metaverse. You can define whatever way the metaverse is, you need an excellent connectivity to make that happen, right? That's why, why
Yeah.
is it's a big deal in Mobile Congress.
No, exactly. And so who do you see? So obviously at Mobile World Congress, we heard from the operators talking about the metaverse and how it becomes fully realized. Who do you see as the big movers? Obviously, Meta is one of them. But who do you see as the big players that are really taking a bet on metaverse?
I mean, almost everybody has to make that as, maybe they'll not bet their farm on the technology, but they have to make sure they're addressing the market because it is the latest trend. If you are not doing it, people might think you are not at the cutting edge of the technology, right? And it used to be high, but the amount of focus that Meta, Facebook has put onto it, kind of they are betting the farm on it. It has become imperative, and then 5G providing this extreme capacity, extreme low latency, made a natural choice for wireless technology to be used for Meta. And then operators like SK Telecom who are looking for, okay, I have deployed 5G. Of course, I mean, Korea is one of the most connected countries in the world. So they are looking at next generation use cases. Their basic broadband connectivities a lot of times are met by 4G itself, which is not the case in many parts of the world. So Korea and Japan are a little bit different than in that sort. So in other parts, in parts of the world, including US, Europe, China, India, Africa, and others, the primary objective, primary duty of 5G will still be to provide excellent mobile broadband connectivity, and then look at the other parts. But I think in Japan and Korea, their basic needs of connectivity are already met. So they're looking at what more I can do with this capacity and abilities that I've gotten with 5G. And SKT has been, from day one of their 5G journey, are focused on AR, VR. So that's one. And also that's where the Wi-Fi comes in as well. So anywhere it is stationary, it's indoors and stuff. Wi-Fi will probably the technology of choice for enabling metaverse, the connectivity choice. And when you're looking at mobile outdoor and other places, then it is 5G. So it is not just one or the other, it is both, right? So then if you consider that, again, from connectivity point of view, who might be driving this? I mean, the same culprits that you see, whoever has excellent connectivity technologies will be driving it from connectivity point of view, and whereas great computer technology will be driving it from device point of view. And since everything will be connected to the cloud players, then the cloud players will be driving it from their end, right? And you'll see the same familiar names. So that's another realization when you go to stuff like events like CES or Mobile Congress, is that you realize that it is not many words, it's all single technology word. Maybe the emphasis is different. Everybody is kind of playing in every parts of the technology ecosystem, right?
No, that's exactly right. And there's more and more convergence,
Correct.
as you said,
Yeah.
on telecom and compute, right? So
Yeah.
it's just, it's an amazing transition.
Yeah.
When you talk,
yeah.
sorry, I was just
So-
going to say, when you were talking about Wi-Fi, it leads me to my next subject, which is really Wi-Fi 7.
Yeah.
I think about what's going on. Most people are still trying to figure out, do I have Wi-Fi 6? Do I have Wi-Fi 6E? How do I get these things? And now we saw ZTE, Qualcomm, MediaTek making big announcements at Mobile World Congress about Wi-Fi 7. Most people didn't realize we had a problem with Wi-Fi 6. And now we're jumping to Wi-Fi 7. So you're being in San Diego, you're pretty close to the Qualcomm folks. What's going on with Wi-Fi 7?
Yeah, sure. So before I jump onto, I just wanted to add and answer your question directly, your previous question, who is betting their farm, who is in investing? You might have seen a lot of announcements where people are to get dedicating resource for meta development, both ecosystem products and services. The latest one was, I think, a couple of days ago, Qualcomm announced $100 million fund to enable and encourage metaverse ecosystem. So I just wanted to make sure it is not peanuts we're talking about. It's like companies like Meta and big companies like Qualcomm, betting
Perfect.
millions of dollars on.
And speaking of connectivity and metaverse, before we jump into this Wi-Fi 7, can you quantify? We have a question from the audience. Can you quantify metaverse connectivity attributes? Examples are latency, capacity to a single user.
Yeah, so sure. So I mean, if you look at AR and XR, right? So if you want to provide excellent what's called as photorealistic user experience, wherein you seem like you are actually in the if you're playing game or you're looking at a video or something like that, you're in the moment. Then for you to have that instant real-time sense, there is a latency factor called a photon to light to photon frequency. So it's in milliseconds. The end-to-end can be maximum 20 millisecond, but which includes everything. And the radio link is one part of it. It could be in single-digit milliseconds, right? So for you to have photorealistic user experience. In terms of capacity, I mean, capacity is pretty straightforward. If you're looking at, if you want to have a HD or a 4K, even going forward 8K, the bandwidth, individual bandwidths goes on increasing. So even for you to have a simple HD or 4K, I think you need consistent 20 to 30 Mbps speed. So that's another thing. It is not about, oh, I'll do a speed check, I'll run a speed test app and I see that, oh, I have like whatever 30, 40 Mbps speed and I'm good to run my system on it. That's not so. You need consistent bandwidth and consistent latency. So even if you have, if you low latency and good bandwidth only when you're testing, that's not enough. You have to have throughout the session of whatever you're doing, be it gaming, be it watching video or interactive activity. You have to have consistent latency and consistent bandwidth. That is extremely hard to achieve in a non-deterministic medium like wireless. Wireless is not deterministic because a lot of it is based on many other factors. If it is a wire line, because it is a dedicated line, it can be deterministic, but wireless is not. That's exactly why you need this URLLC, 5G advanced, 6G, even a lot of it is in Wi-Fi 7 as well. That's why you need those. I hope that I addressed that question.
Yeah, no, thank you. So back to Wi-Fi 7, that starts to answer the question, right? So
correct. Yeah. So
it's all about latency and bandwidth.
Correct.
And so for our audience, can you just talk a little bit at a high level? What's the difference between Wi-Fi 6 and 6E and Wi-Fi 7?
Okay. So Wi-Fi 6, it's called as 11AX standard from IEEE. I mean, it was commercialized probably, I think, 4 years ago, and it's been, all the latest devices mostly have 11AX, especially the premium devices. 11AX brought OFDMA first time to so far it was all OFDM, brought OFDMA to Wi-Fi, and Wi-Fi 6 is when Wi-Fi networks started looking like cellular networks from many aspects: manageability, multiple access, and so on. And then the Wi-Fi has become so popular. There are more spectrum given to it, especially the recent what's called as Wi-Fi 6E with close to 1200 megahertz of 6 gigahertz spectrum. That is huge bandwidth. For comparison, I think 2.4 gigahertz, which is the first bandwidth, first spectrum for Wi-Fi, had 60 to 80 megahertz of total bandwidth. And then Wi-Fi 6 or the 11AC, the 5 gigahertz, which came with 11AC, they had around 400 to 500 megahertz of bandwidth, depending on the region. When with 6 gigahertz, it's close to 1200 megahertz of spectrum that is available. So it's huge amount of bandwidth. So when one of the challenges with that different spectrum is how you make sure you best utilize all this spectrum in an efficient way is one of the challenges that Wi-Fi ecosystem, Wi-Fi players faced when developing the next generation of technology, which is Wi-Fi 7, right? So, and other key thing was, Wi-Fi is unlicensed, so anybody could use it at any time, of course, based on the spectrum requirements and so on. So making this unlicensed spectrum or any technology that uses unlicensed spectrum, remember I said deterministic for these new age use cases, it is very hard. So some of the things that Wi-Fi 7 is trying to do is bring in features that make it deterministic. So what are some of those features? Obviously, if you have multiple bands, you use not just rely on only one band at a time for your connectivity, have multiple bands connected together. So you have similar to how it is done in cellular as well, called carrier aggregation. So you're connected on simultaneously on two different bands. So even if there is congestion or even if challenges or issues with one band, you can still rely on the other band for your connectivity. So through that, you provide deterministic connectivity and provide deterministic and consistent latency and spectrum, right? So that's one of the key things. And obviously, it supports very wide bandwidth. With Wi-Fi 6, it was only up to 160 megahertz. With Wi-Fi 7, you can go up to 320 megahertz of bandwidth. And then there's another, and then you basically can combine with what's called as multi-link, these spectrums and multiple channels together to have wider this 320 megahertz of bandwidth. And also the other important aspect is, there's a lot of incumbents in many of these spectrums. So although, your device and the network is capable of utilizing this wider bandwidth, is 160 megahertz or 320 megahertz, if there is a narrow band, it could be even a 20 megahertz interference in between, you could not, you have to, there will be interference. So you'll not be able to use those wider bandwidth. So you'll have to, go to a lower bandwidth. So there are some, interesting things that are being done in Wi-Fi 7 that you basically blank out that very narrow bandwidth and you can still have wider bandwidth. So for example, if I want to have say 320 megahertz of bandwidth, which is, 160 megahertz joined together, for example, if there is a 20 megahertz interference in one of those 160 megahertz bands, I could not use that second band at all. So I could just have to contend with 160 megahertz of channel bandwidth. So with this new feature, it's called a preamble puncturing. I puncture the second 160 megahertz for that whatever 20 megahertz of bandwidth, but I can still have 300 megahertz of bandwidth together. So the whole idea is you get wider bandwidth, but you also get wider bandwidth in many cases, in most of the use cases, most of locations, and most of the time.
And so the announcements we saw were about silicon primarily. When do you see products, Wi-Fi 7 enabled products, hitting the market?
So you actually talked about the announcements that were done before, during, and some after the Mobile World Congress event as well. As you said, the news cycle for Mobile Congress is almost a month now. 2 or 3 weeks before is when the early announcement starts coming in, and they can run till 2 weeks after the event. So some of the announcement that you are showing on the screen were the products themselves. Some are people doing the demos, and some are with the devices. So I expect the products to be made in second half of this year. These are the chips, like the Qualcomm was a chipset that they announced, and then MediaTek was a demo that they did. ZTE was a device. So it's not a lab demonstration. It's kind of actual products like this Fast Connect 7800 is actually a chipset that goes into devices, so the networking and the consumer devices.
So it's interesting. The Wi-Fi 7 is almost moving into the automated carrier aggregation space, where you can take channels side by side and really enrich that environment. And I think that the really interesting thing there is, as the speed for the cellular networks increase, it does put some competition on the Wi-Fi space to keep up, to make sure that they have a viable solution, so that people aren't just thinking, well, maybe I can consider a complete cellular solution for my offering. So it's interesting to see this going on. And to that end, why don't we wander into the world of 5G advanced and 6G. It's interesting, so when we were in the 4G world, the carriers started getting a little crazy on the marketing front and telling us that we're in 4G evolution, or some of them just started saying we're in 5G, and they weren't in 5G. It was great for marketing, but in reality, it wasn't. And now we have millimeter wave out there, which is a big improvement in 5G. But talk a bit about 5G advanced.
Yeah, so I mean, people have been talking about 5G from last almost 3 or 4 years now. So, marketing folks always want something new to talk about, right? So obviously, numerically, 6G comes after 5G, so it is natural for them to jump to 6G discussions as such. Before we go there, I want to level set a little bit. So, although we have talked about 5G for last 3-4 years, even more in some cases, and we have had 5G networks technically from last 3 years, but in a major way, at least in the developed markets, in last 1.5 to 2 years, we are still at the first step of 5G. 5G had this grand promise of many things, and people expected all of that to be available from day one, which never happens. So we are only at the first, even that too in developed markets, be it US, Europe, and China. We are still at the first phase or the first step of 5G, which is called as enhanced mobile broadband. Where you have gigabit speeds, extreme capacity, and so on, that we talked about a little bit, before during this call as well, right? So there is many other aspects of 5G are yet to be realized. They're still being developed, not even commercialized, developed, and then ultimately will be commercialized. So like some of the things like massive IoT, URLLC, Industry 4.0, and so on, right? So that is one thing. And this is only in the developed markets. If you look at the emerging markets, like large swaths in India, for example, Africa and others, 5G is not there yet. And in many cases, the spectrum is being allocated as we speak, maybe sometime this year and so on. So we have to keep that in mind when we talk about the evolution. Okay, so that's where we are. And then whether what is after 5G, whether it's 6G or not, well, then the folks that develop these things, 3GPP is one of them, which developed the standards for all these cellular technologies. And by the way, I'm a 3GPP member. So they said, wait a minute, it's getting out of control right now. So then they looked at 5G is, in terms of people who follow the standards, 5G was defined in release 15. So the commercial networks that are out there right now are all release 15 standard. So they are based on the first standard or the first release of 5G standard. So release 16 was finalized June of last year. Release 17 is being worked on, and release 17 will be commercialized mid or third quarter of this year, right? So all of them, those are three, they're all 5G. And then the work for release 18 has started. It started late last year, and the definition itself has started. So then 3GPP said, so we will come up with what is called as a evolutionary step called 5G advanced, and 5G advanced will be from 3GPP release 18 and beyond. It will definitely have at least 2 releases, maybe 3, which is release 18, 19, and possibly 20 as well. We don't know yet. But release 18 and 19 will be called 5G advanced, and then 6G might come after that, right? Even in release 15, which defined 5G, there are a lot of standard specifications for LTE as well. So it's an iterative process, and it is a continuous process. So what is 5G advanced looking at? 5G advanced is looking at obviously improving whatever is introduced in release 15, 16, and 17, improving upon them. Right, by the way, so if you want to know what is in release 15, 16, and 17, I actually published a white paper, a report on what release 17 has, and what 16, 15 have as well, on my website. I think I will show a link to that, where the reports are a little bit later. You can check it out. Okay, so 5G Advanced is looking at improving everything that was introduced in 16, 15, and 17 in terms of broadband, URLC, and other things. But it is primarily looking at enabling industry verticals to use 5G. I mean, be it broadband, be it many IoT applications, verticals, be it, mining, based in industrial, be it shipping and stuff like that. All the verticals which have very diverse needs, it is trying to address that. That is one major thing. And second, looking at bringing AI and ML, artificial intelligence and machine learning, into radio link itself. Of course, there are AI and ML applications which will run on 5G and its evolutions. But here, if you look at the radio link between the radio and the device, which is kind of rigid right now, right? It is defined by the protocols, the 5G protocols or the LTE protocol that it is being used, making that itself very dynamic. And you have AI algorithms running on the network and on the device, and then working together, called as cross learning, and making sure converging on an interface between them, which basically best suited for the type of application that the device in the network is running, the use cases, and so on. So make it very dynamic, not rigid right now, right? That's one of the key areas. And the other thing is looking at is energy efficiency. I mean, of course, networks consume a lot of power, and power consumption of not only cloud infrastructure, but also network infrastructure is also under a lot of pressure as such to reduce energy consumption. And by the way, it's nothing new for 3GPP. It's been working on it for a long time. I mean, devices are so power constrained and battery constrained. By definition, the technologies they work on are more power efficient, but there is even more emphasis on it in 5G Advanced. Second, and third is what's called as duplex. I mean, I know there are multiple ways of duplex. Duplexing is you're doing both uplink and downlink simultaneously. You might say, okay, we already do it now with when 3G, 4G, and 5G. But what we do now is we use separate spectrum bands, separate by at least 30 to 40 megahertz. Separate spectrum bands for uplink and downlink simultaneous use. So now with a lot of TDD spectrum, a lot of the new spectrum is in TDD, and using a TDD, I would say unpaired. There is a lot of new spectrum is unpaired. So one way to use that unpaired spectrum is use TDD, time division duplexing. But time TDD adds in a lot of latency into it, because you're using only a downlink or the uplink at a time. So if you have to send something immediately on the uplink, you have to wait till your turn comes for the uplink and send it. That adds a lot of latency. So, but if you're looking at URLLC type of communications, you can't possibly do that with TDD. So you need what is called as same band, single frequency, or same band, sub-band duplexing. So the first step of that called sub-band duplexing is in 5G Advanced, wherein you take the same band, and within the sub-bands, you can basically use uplink and downlink, so the latency is minimized. A next step to that would be you use the same frequency, same band for both uplink and downlink. So it's single frequency duplexing. So you need to do a lot of interference cancellation, self-interference cancellation, and so on. So that's where the industry is working on. So a lot of things to think about, but to summarize it, 3 things to remember about 5G Advanced: AI ML to make the airlink dynamic, reducing power consumption, network power consumption, and third is duplexing, same frequency duplexing.
Perfect. And then, so if we look at 3GPP and their current schedule with 15, 16, 17, and then 18, what work has been done looking at 6G? Since we heard people talking about it at the event. What is this, just marketing speak at this point? Has 3GPP put any effort into this yet?
There is some marketing speak, but these basic technologies take like close to 10 years to develop. So what is standardized, it takes like 6 to 8 years of basic concept work and a developing proof of concept, and then bringing that to standards and standardizing and commercializing. So the work on 6G, the concept of 6G, it's not that developing products, but how to define what basic concept which provide this next generation shift in performance, bring what concepts can bring this next shift, generational shift in performance has already started. So they're at a very conceptual stage, and obviously there is a marketing aura about 6G to keep people interested, but the basic work has started, but it is far away from being standardized and even farther away from being commercialized. So another tidbit to look at, people who have worked in these standards for some time, like me, who have made their made their hair gray in this, know that no new concept comes in standardized and commercialized in one release. It is, as I said, iterative process. So if you take, for example, what was mainstream in 4G, which is mass market broadband, it was not introduced in 4G. It was introduced in the advanced phases of 3G and made mainstream in 4G. And what is mainstream in 4G, like massive MIMO, we talked about massive IoT, extreme bandwidth and so on, they were not introduced in 5G. They were introduced in the advanced phases of 4G. So they were commercialized. So if you look at what will be in 6G, the instinctive answer would be look at what is being introduced in 5G advanced, and that kind of will be commercialized in 6G. Obviously, there'll be new concept that will be introduced and then perfected in the future phases and so on, right? So that kind of gives you the directional view of what 6G can be.
Right. Thank you for that, Prakash. Obviously, we just introduced millimeter wave to 5G, and that's been a quantum leap forward in terms of performance. And so advanced obviously makes some sense, because there is no way a body like 3GPP could start finalizing specifications when some of the concepts are still being developed. So
yeah, and in terms of spectrum, they're looking at, when you're using all the spectrum, in 5G currently have some part of millimeter wave is used, mainly in US and few other places.
Yep.
But a lot of the global networks are on mid-band spectrum, which is sub 6 as well, lower than 6. Now these future releases are looking at 6G might be where they will be available 7 to 14 megahertz of spectrum, which is higher mid-band as it's called, and they're looking at 100 beyond 100 megahertz of higher band spectrum. It's called as sub terahertz spectrum. So spectrum is always in play when you're developing new standards.
Gotcha. Well, that's perfect. And so just to come back to the beginning here, we talked about 4 disparate areas that were pretty prevalent at Mobile World Congress: Open RAN, Metaverse, Wi-Fi 7, and then 5G Advanced and 6G. And you could see that the key here is convergence between communications and compute. And what that means is better, more economical solutions that are being brought to market. So that's pretty exciting. So thank you for that, Prakash. We have a couple of questions, so let me get to those. On 5G private networks, is there any good market research reports or data to look at for market TAM, CAGR growth in this sector? And how much of this 5G private network is 5G FR1 versus 5G FR2?
I think there are tons of all the major analyst houses, be it IDC, IHS Market, and others have tons of spectrum. There are like many the niche players, be it mobile experts, and few others have as well. So if you look around, there are lots of them, and obviously it's a new field. They keep them fine tuning as the time goes by. There are available for people looking at those specific numbers, and then probably I mean FR2, which is millimeter wave for people who don't know, has a role to play, especially in factory indoor deployments with robotics, robotic vehicles and so on, which need very high bandwidth and so on. But the initial deployments will probably be based on mid-band FR1, and it also depends on the use cases. If it is a campus deployment with a lot of outdoor, then probably FR1 makes sense. But if it is indoor in factory deployments for robotics, moving robotics, automated vehicles and so on, then FR2 makes sense there as well.
Perfect. Well, thank you there, Prakash, for that answer. We're wrapping up here. We've just gone over our hour together. Before we leave, I would like to take a moment to thank our sponsors. Our WCA is a nonprofit organization, and we bring events to you like this based on the generosity of our sponsors. And so we appreciate them. And if you'd like to learn more about becoming a sponsor or sponsoring an event, go to www.wca.org and take a look at that. And we appreciate your support. Prakash, I have a gratuitous plug for Prakash on how to connect with him. You can see his Twitter, LinkedIn, podcast, newsletter, and the website for Tantra Analyst. So he's pretty easy to get a hold of. And so with that, I'll say thank you to everyone. Thank you for your time. Thank you for participating. Please join us on April 21st, where we will be hosting a session on wireless power and energy harvesting. And focus there will be talking about real applications. Like many things we talk about at the WCA, we want to show the real world scenarios of these technologies and who's using them, how they're being used, and not just talking about things that might happen in the future. So we hope you'll join us. And with that, I'll sign off. Prakash, thank you for your time. It's always a pleasure having you join us on a WCA event. And thank you all for joining us. Have a good day.
Glad to be here as well. Thank you. Have a good day.